Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare. This is my continuing feature on my three-volume series of Math Lovers book, and I'm up to section 3.4 of volume 1, where I've been talking about Fibonacci numbers and the golden ratio. And this is my third video on that series, my second on the golden ratio. Today I'm going to talk about something called the golden section, which is a useful way to define the golden ratio. So anyway, let's begin. So here's the way we define the golden section. Imagine we start with a line segment of arbitrary length. I'm just calling it L. And then what we do is we want to divide this line segment into two smaller line segments in such a way that you have a large piece and a small piece, and we want the ratio of a large piece, the length of the large piece to the length of the small piece, to be equal to the ratio of the length of the whole interval we started with over the length of the large piece. So that's how we're defining the golden section. And it's a unique ratio that does this, that solves this problem. And so if we call the whole length L, and say we call the length of the large piece L1 and the length of the small piece L2, then we want is L to equal L1 plus L2, but we also want the ratio L over L1 to equal L1 over L2. And we can call that ratio phi, the golden ratio. That's what we're defining phi. So, and now we can calculate phi based on this definition. We just write everything in terms of L and phi. Or actually, I think it's probably better to do it in terms of L2 and phi. Yeah. So L2, remember, was the length of the shortest piece. And then the longest piece is L1, that's phi times L2. And then the whole piece is L, which is phi times L1. So we have L is phi L1, but L1 is phi L2. So that means L is phi squared L2. And remember that they have to add up to L. So we have phi L2 plus L2 equals phi squared L2. If you divide that whole equation by L2, you just get phi squared equals phi plus 1. That's an algebraic equation for phi. And we can write it as a quadratic equation just by subtracting the right side from both sides. If we do that, we get phi squared minus phi minus 1 equals 0. That's a quadratic equation for phi. And I think you guys know the quadratic formula for computing roots to quadratic equations. If you apply the quadratic formula here, you see that a is 1, b and c are both minus 1. So when you apply the quadratic formula, you're going to get b squared minus 4ac equals 5, and negative b is 1. So you get 1 plus or minus square root of 5 over 2. But we want to use the root with a plus sign because the other one is negative. And we know the ratio is not negative, the ratio is positive. So the ratio is the golden ratio, and we have a formula for it, 1 plus square root of 5 over 2. So that's the derivation of the formula for the golden ratio if you define it in terms of the golden section, which I think is a very useful construction. And there's a lot more geometric interpretations of the golden ratio, which I'm going to get to later. So anyway, this is just one of them. That concludes my video for today on the golden section. Thank you for watching. Long live math, and I'll see you guys next time. Bye.